Hello guys, here's our example problem for section 2.6. There's lots of different types of problems in this section, so I just picked one. I went with one with slant asymptotes, but if you want to see something else, just let me know and I can do a video of something else. So, for slant asymptotes, the degree on top needs to be exactly one higher than the degree on the bottom. So that's how we know we have a slant asymptote, other than the fact that obviously it's asking for the slant asymptote. In order to find the slant asymptote, we are doing the division that is listed in the fraction. So x squared minus 49 divided by x. I'm going to do this one with long division. Okay. Because synthetic, I think, would be a little weird. This is kind of like x plus 0, so you would have 0 in the box. I mean, I guess it would work, but I'm going to do it with long division. Then maybe I'll also do it with synthetic so you guys can see. One thing to keep in mind, you have to have placeholders for terms that you skip. So I have to put in 0x minus 49 so that everything stays lined up when we start working this. So x times what is x squared? That's x. So then I multiply x times x is x squared, and I'm subtracting, so I get 0, and I bring down the 0x. X times what is 0x? That's just 0. 0 times x is 0x. It seems kind of silly doing it with these zeros, but and obviously that's still 0. That's nothing. We bring down the minus 49. That would be our remainder. Okay, our remainder. Now, it is weird, like this is just a weird problem because we're only dividing by x. But the important part for slant asymptotes is the quotient. The quotient here. Our answer is y equals x with a remainder of negative 49, but we don't care about the remainder. Y equals x is our slant asymptote. And if you graph y equals x, that's just a diagonal line with a slope of 1, right? There's a 1 here. And if we think about y equals mx plus b, all of our slant asymptotes are going to be in this format. And you'll have a y-intercept where you start and a slope that you follow from there. It just happens for this problem, our y-intercept was 0, because there's nothing there, and our slope is 1. Okay, first we're going to talk about symmetry. Let's see. For symmetry, we're plugging in negative x. We're doing that every time we check for symmetry. Okay. So the negative x, when we square it, becomes positive x squared minus 49 over negative x. Now, one thing you got to be careful of with the fractions, people will look at this sometimes and will incorrectly think that this is neither because we had some signs that changed, or some signs that changed and some signs that stayed the same. But if you think about fractions and what the opposite sign on a fraction looks like, let's say I had 1/3. The opposite of 1/3 is negative 1/3. Now I can write it like that. I can also technically write it like that. That would be the same thing. But if you notice, it's not negative 1 over negative 3. That's not what we do when we do the opposite of 1/3. That's not it. So we're not looking for both signs to change. We're not looking for a sign change on top and a sign change on the bottom. We're really only looking for one or the other. So since the bottom changed signs, okay, since the bottom changed signs, this is equivalent to the opposite of what we started with, right? I can pull that negative out front and write it like this. Okay, this is the opposite of what we started with, so that makes it origin symmetry. Okay, y-intercept, you just plug in x equals 0. The y-intercept, we plug in x equals 0. Well, that's going to be a problem because I'm going to end up dividing by 0 here. So I can't have a y-intercept because I can't divide by 0. For the x-intercept, we set it equal to 0. Okay, setting it equal to 0. Let me erase some of this. Sorry, that's obnoxious. It takes forever. Okay. So x squared minus 49 over x equals 0. Now, anytime you're setting a fraction equal to 0, the denominator won't matter because I'm going to multiply by the denominator on both sides. It will cancel out on this side, but on the other side, it'll still equal x. So I get x squared minus 49. I'm sorry, it'll still equal 0. 0 times x. So essentially, you end up with just the numerator equal to 0. Then I'm going to add the 49. And then when I square root it, I have to remember my plus or minus. Okay? Anytime you square root it, you have a plus or minus. So this wants us to use a comma to separate answers and to type them as an integer, which means I'm not typing them as an ordered pair. I'm not doing 7, 0. I'm just typing them individually. So 7 and negative 7. Okay? The vertical asymptotes come from whatever x values will make the denominator 0 after you've canceled out anything that might happen to cancel out. But in this one, nothing cancels. So whatever x values will make the denominator 0. In this case, the denominator is just x. So the x value that will make that 0 is 0. You can't just go in here and type 0. You have to read the instructions. It says the equations of the vertical asymptote. A vertical line means it's x equals whatever number. So we're using x equals 0. If you don't type it as an equation, it is wrong. Okay? That's not MyMathLab grading something wrong. That's you not following directions. You have to read the directions. Okay? And horizontal asymptotes. Anytime you have a slant asymptote, you're not going to have a horizontal asymptote. The rule for horizontal says if the degree on top is larger than the degree on the bottom, there is no horizontal asymptote. Okay, they want us to type in some points and they want us to do these as fractions. So I'm going to pause for a second and fill this out. All we're doing is plugging in for x, but it takes a little bit, so I'm going to pause so I don't take up so much time. Okay guys, I'm back. You just need to make sure that when you do these, you do them as fractions and you simplify them if they can be simplified. But all it was plugging in -9 for x in both spots and just simplifying. So -9 squared was 81. 81 minus 49 was 32. But then we were dividing by -9, so that's why there's negative out front. And then you just go through and you do all of them. All right, so use the information obtained in the previous steps to graph the function. So we know, first off, that it should have two x-intercepts. We know the vertical asymptote is at 0. We know that the line y equals x is our slant asymptote. So if you're not sure, y equals x is a very specific line. Y equals x, if I'm graphing, has a y-intercept of 0 and a slope of 1 because it's got a 1 in front of the x. So it's up 1 over 1, up 1 over 1. So you end up with this diagonal line as your slant asymptote. So we have to pick the graph with the right picture. So first of all, A, oh my goodness, okay. A has the wrong slant asymptote, so I know it's not A. And D has the wrong slant asymptote, so I know it's not D. Okay? Because those are negative x, those are slanting the wrong way. So then when I look at B and C, one thing I notice about C is it doesn't have any x-intercepts. Right? We found that we need x-intercepts at 7 and negative 7. So it can't be C. So B is our only option. And if I look, and there's my x-intercept at negative 7 and at positive 7. Here's my vertical asymptote and my slant asymptote. So this is B. Okay? So if you have any questions about any of this, let me know. If there's something specific you want to see or want me to talk about, I can do that. All right, have a good one.